Hi everyone, in this video you will learn how to Dockerize a machine learning application, and this tutorial consists of two parts. In the first part we build our Flask app and apply the machine learning model, and in the second part we Dockerize everything. And for this I actually got help from Francesco, who is a Docker captain and a real expert in this field.
Hello everyone, and thanks for the introduction. I'm Francesco, Docker captain, and I like to help developers understand containerization concepts. You can find me on Twitter and YouTube in the links below. In the second part, we will take care to containerize the application that Patrick is about to create. Let's start!
So the second part is available on his channel, and I will put the link in the description below. And now let's get started. Alright, so let's start from scratch by developing our machine learning model and our web app. And for this, I have one empty directory that I called app, and then I have another one that I called MLDev. So this is where we do our machine learning development. And yeah, here we don't start completely from scratch, so I already have the data here and a notebook where we train and come up with our model. So this is not the focus of this video, but you will learn how we transfer our notebook to a production-ready web app. So let's do this. And yeah, let's go into the ML dev folder. And if you are working with machine learning stuff, then the chances are pretty high that you use a Conda environment. So I want to use the same in here. So we start from scratch by setting up a Conda environment. So I say Conda create -n, and then I give it a name. And I also like to specify the Python version I want. So here I want Python 3.9. So hit enter. And you don't need to use a Conda environment, but I recommend that you use at least one kind of virtual env management. So you could also just use the built-in virtual env. This works just fine. But in this case, I want to demonstrate how to do this with a Conda environment. So now we activate it. And the great thing later will be that when we have our Docker container, then we no longer have to worry about this local setup here. So then everything should work in our Docker container. But for now, we have to set up this locally. So yeah, now we have this activated, and now we can install all the packages we want. So the first thing I install is Jupyter and IPyKernel for the Jupyter notebook support. Then I also want to install a kernel for this environment. So I say IPython kernel install --user --name. And for the kernel name, I give it the name as the environment, so also NLP. And now I need to install all the packages I need to develop the model. So in this case, I'm going to use scikit-learn. But the same approach works also with TensorFlow models or PyTorch models. So in this example, I want to keep it simple, but again, the approach is the very same for any kind of machine learning or deep learning app. So now we have this, and in this example, I need one more package, and this is the NLTK package to work with text. And now we should have everything we need. So now we can start our notebook by saying Jupyter notebook. And this fires up the server, and here we see the data, and this is the notebook I prepared. So this is the notebook, and I will upload this to GitHub and put the link in the description. And now we go over this only very briefly. So what we're doing here is we work on a project to classify Twitter tweets and say if they are positive or negative. So the first thing I want to do is change the kernel and make sure that we use the kernel from the environment that we just created. So we select this NLP, and then let's run the first cell and see if all the imports work. And here we get a error, module not found. So I forgot to install this in the environment. So let's go back to a kernel, to the terminal, and then activate this in a new window, Conda activate NLP, and then we say Conda install pandas and hit enter. All right, so now we have pandas. So now let's go back and run this again. And now the imports work. So yeah, and then now let's go over this briefly. So here we load the data, and again, I will put the link for the dataset in the description below so you can download this as well. And then we do some text pre-processing. So here we define emojis and stop words. And then I created one function pre-process that gets the raw text data. And then here, for example, I remove URL patterns, the user patterns, and then I remove stop words. And I apply this lemmatizer. And the lemmatizer is a popular technique in NLP that groups together inflected forms, for example, better and good. So we instantiate this here, and this is available in the NLTK package. And when you run this the first time, you might get an error and a note that you need to execute this command. So we have to say import NLTK and then download this package and this package. So this is important because we have to remember this for later, because we have to do the same commands in our Docker container. But yeah, this is the pre-processing. So we define this function, then we call this with the and get the pre-processed text. And here I do a train test split, and then I set up all the different models or pipeline steps I need. So the first thing here is to use a vectorizer. So I set this up and call vectorizer fit and then vectorizer transform. And then I try out different classification models as last step. So here I have this helper function to evaluate the model. And yeah, here I create different models, for example, this Bernoulli naive Bayes, and then call model fit and model evaluate. And yeah, once we've done this and decided for the final best model, now the next thing to do is to save all the different steps and all the trained models and then load this in our application. But in this case, I want to show you one best practice that you can use with the sklearn package. And for this, we use the sklearn pipeline. And the way it works is that we define a pipeline object where we put in all the different steps. So the first step is the vectorizer and the second step is the final classification model. And then we have everything together. So now I have to only call one fit command and then one predict command, and don't have to call the vectorizer and the Bernoulli model separately. So yeah, I recommend that you set up a pipeline like this, and then here I evaluate it again to see if this still gets the same results. And now we have to only save one trained pipeline. So after having set pipeline.fit, we now save this pipeline, and for this we use the pickle module. And then we load this again, and here I call model evaluate to check if this is still the same. And yeah, this approach is the same for every machine learning pipeline. So if you use TensorFlow or PyTorch, then also at some point you want to save either all the steps separately, or maybe you could save the whole pipeline in one step. And then later in your application, we call model load again. So yeah, this is how we save and load the model. And then here at the very end, I have one function to predict the text. So here we call this pre-process function. So this step is still separately because this is not a model that we can put in our pipeline. But then here we only call model predict. So this will apply the vectorizer and the final classification model. And then it returns the label. So here I test this with some example tweets. So now let's run all the cells and hope that this works. All right, so the code ran through and now we see the final output. So here we have the classification. I hate Twitter. This is class 0, which means negative. May the force be with you. This is 1, which means positive. And then here again, we have one negative tweet. So yeah, our classification works. And now we have all the code we need in the notebook. And now the next step is to transfer the code that we need from here to our application. So let's go back to our folder. And if we go to the ML dev folder, then here we should see our pickled file. So this is the pipeline. So the first thing I want to do is I want to copy this over to the app. And now let's go back to the terminal. And here we can quit the server. So we no longer need our notebook. And now let's go back and into the app folder. And here I fire up my code editor. So in here, the first thing I want to do is I create another folder and I call this API. And then in here, again, a new folder, and I want to call this models. And then I move the saved model into this folder. So now we have this, and then in the API folder, I want to create two files. So I want to have one app.py and another one, and we call this utilities.py. So yeah, so now we have the app.py, the utilities.py, and the models with the saved model. And now the first thing to do is to bring over the code from the notebook to the utilities file. So let's put this next to each other. And now let's bring over all the code that we need. So we need a few imports. So we need import ray and pickle. Then we need this lemmatizer. So let's copy and paste this. And then if we go down, so we don't need this data set, but we need the emojis and the stop words for the pre-processing. So again, let's copy this, and I will make this smaller for now. So yeah, here we copied this. Then we need this pre-processing and the lemmatizer. So let's copy and paste this whole function. And then again, here we don't need this train test split stuff, and we also don't need the stuff where we set up the different models and fit them and evaluate them. So the only thing we need at the end, we also don't need this pipeline stuff. We only need this where we load the pickled file again. So let's copy and paste this as well. And here we have to be careful. So this is now in the models folder. So we say models/pipeline.pickle file. And then let's go down further. So yeah, we could also use this predict function and maybe this with if name equals main to test the code. So now we should have all the code that we need. And now let me reformat this a little bit. So I want to put the lemmatizer up here so that we see it right away. Then I also want to have this where I load the model at the top so that I see this right away as well. And then let's create one final function, and I will call this define predict pipeline, and this only gets the final text. And then here we can say return predict, because this function still gets the model. So down here it gets the model and the text. So here we say predict, and then we put in the loaded pipe and the text. And then this is basically the only function we have to call. And then down here, let's say predict pipeline, and then it only gets the text. And then I can close the notebook and make this larger again. And now let's open the terminal in here. So in here, I want to run this and make sure that this works. So now let's make this larger again. And the first thing in the terminal I want to do is make sure that I'm in the correct environment. So like you can see here, this is a different one that was activated by default. So I deactivate this and say conda activate NLP. And now let's go into the API folder, and then we can run python utilities.py. And yeah, this works. So here we should now see the same output that we've seen in our notebook. So this works as well. Now we have all the code for our model classification that we need here. And the last thing to do is now to implement the Flask app. So for this, we use Flask. And of course, we have to install this. And here I'm simply going to install this in our Conda environment, but I install it with pip, so I can say pip install Flask, and this works just fine. All right, so now we have Flask. So now let's import the stuff we need. So we say from Flask, we import Flask. Then I also want JSONify, and I also want request. And then we say from utilities, we want to import the predict pipeline function. This is all we need from there. Then we set up our app. So we say app is our Flask app with the underscore name convention. And then we need to create one function, and we call this, let's call this predict function. And for now we say pass, and we have to decorate this, of course. So here we say add and then app dot, and now this is new since Flask 2.0, we can say app dot post, so for a post request. And then we define the URL endpoint. So we say this should be at /predict. And here what we want to do is we want to basically send a text to this endpoint as JSON data. And here we get the text and then call the predict pipeline. So the first thing we do is we say data equals request.json. And then since we want to deploy this to production, I also want to do a couple of error checking here. So I wrap this in a try except block and then say the sample equals the data with the key, let's call this text. So now the user should put in a JSON file with the key text, and otherwise we get a key error. So we say except, and then we catch a key error. And here we can say we want to return JSONify, and then this should be a dictionary where we put in the key error, and then as a message we could maybe say no text was sent. So yeah, otherwise it works. And then we have the sample, and this is a raw string right now. So we want to put this in a list. So we need a list with at least one element. So we say sample equals a list with this item. And then we call the predictions pipeline. So we say predictions equals predict pipeline, and this only gets the one sample now. And then again we could do some more error checking with this, but yeah, I leave this up to you. But now for the very end I want to do one more error checking. So here I want to say results equals, and then again I want to JSONify this, and then I put in the first predictions. So this should again have only one element. So I can say predictions and then 0. And if this does not work, then this will, or this could maybe throw a type error, and I show you why in a second. So we catch a type error as E, and then here again we can return a error as JSON object, and here I want to make the exception message as a string. And otherwise, or we say this is also the result, and then at the very end we return the result. So yeah, this is basically all we need for our predict endpoint. And now again I want to say if underscore name equals underscore main, then I want to test my Flask app, and I want to say app.run, and here I give it host, the host object equals as a string 0.0.0.0.0. And while I'm debugging this and trying this, I can simply still say debug equals true. This uses the internal Flask development server, so this is fine because later we use a production ready server and not this one. So now let's test this again by going to our terminal, and then this case we run python app.py, and this should start the Flask server. So yeah, this is up and running, and now we can go to a separate terminal and then use a curl command to send a post request to this endpoint. So let me copy and paste this in here. So we say curl and then a post request, and we need to send this JSON data with it. So here we have the key text, and then we use this tweet. And then here we have this endpoint at port 5000 and then /predict. So let's run this and see what happens. And we get a response back, so the endpoint worked, but we get an error. Object of type int64 is not JSON serializable. And so what happened here is that in our application, if we go back and have a look at here, so here we catch this type error. And this is exactly what happened, because now if we go back to the predict pipeline, and in the predict function, so here, this prediction is a NumPy data type and not a Python int. So we have to convert this to a integer. And in fact, I want to do this a little bit different. So instead of putting a tuple in here, I want to create a dictionary. So this will look nice in JSON format. So let's create a dictionary from this. So this needs a key. So here we put in the key text and then the text. Then we put in the key, let's call this pred for prediction. And then here we want to put in the label. And yeah, this is the label to prediction, or the other way around, prediction to label. So yeah, so now we have this. So let's save this and run this. And this is still in debug modus. So if we go back, then this should be reloaded. So now let's do the curl command again. And now it says connection refused. So I think I accidentally quitted this because here I have a syntax error. So if we go back, then of course here this should be before the colon. So now it should work. So now let's run our app again and see if this is up and running. So yeah, now our app is running again. So now let's send a curl command again. And yeah, now it works. So now we get the correct prediction back where we see the label, the prediction, and the original text. So now let's also test this with the negative one. So here we send the text, I hate Twitter. And then we get the negative label. So yeah, this worked. So now our app is running, and now we want to Dockerize this. So before we do this, I want to do one more thing. So in our API folder, I create one file, requirements.txt, and this is where I put in all the packages that I need. So what we can do here is, if we go back to the terminal and quit our application, so since we used a conda environment, we can say conda list, and this will list all the packages that we have here. But here we basically only need to grab the ones that I installed in the beginning. So conda installs a bunch more. So we need scikit-learn, and we also see the version here, and I highly recommend that you put in the version in the requirements.txt file as well and pin this, because if we have a difference between the versions where we trained our model and then later when we load this and do it in our app, if there is a difference, then our app or our model could break or produce different results. So we want to have the same version for scikit-learn, and I recommend the same if you use TensorFlow or PyTorch. So we pin the version here, and then we also need the NLTK. So let's search for this. So here we have NLTK, and then let's also copy and paste this and pin the version to 3.6.6. And then we also need Flask. So let's search for Flask and copy and paste this. And yeah, for Flask, it doesn't really matter, but I recommend that this should be at least 2.0, because then we can use this app.post command. So let's pin this to at least 2.0. So we can say greater equals 2.0.0. And then this is all that we need. And I also want to write a comment here. So I copy and paste this. So this is a command that we need to import NLTK and download the packages for NLTK. So I put this here as a comment as well. And then, yeah, Francesco can see this. And now we have everything we need for our web app. So we have this one directory with the API. And here we have our Flask app up and running. And yeah, as a next step, we want to Dockerize this. And as I said in the beginning, you can find this on Francesco's channel. So I hope you enjoyed this tutorial, and then I hope to see you next time. Bye.